Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 5, Section 2, Chapter 4, Topic 1.
Process control systems, PCs, are integral components of semiconductor packaging manufacturing facilities, playing a crucial role in ensuring consistent, high-quality production processes. These systems encompass a range of hardware and software tools designed to monitor, regulate, and optimize various aspects of the packaging process. From controlling equipment parameters to managing material flow and maintaining environmental conditions, PCs are essential for achieving efficiency, reliability, and product uniformity in semiconductor packaging. In this comprehensive overview, we will delve into the intricacies of process control systems, exploring their functions, components, applications, and importance in semiconductor packaging. Introduction to Process Control Systems, PCs. Process control systems, PCs, are sophisticated systems employed in semiconductor packaging facilities to monitor, control, and optimize manufacturing processes. These systems integrate advanced hardware, sensors, actuators, and software algorithms to maintain precise control over various parameters, ensuring consistent product quality, performance, and reliability. Functions of process control systems. PCs perform a multitude of functions to regulate and optimize semiconductor packaging processes, including A. Process monitoring. PCs continuously monitor key process parameters, such as temperature, pressure, flow rates, humidity, and chemical concentrations, to ensure adherence to specified tolerances and standards. B. Process regulation. By adjusting equipment settings, material flow rates, and environmental conditions in real time, PCs regulate process parameters to maintain optimal operating conditions and minimize deviations from target values. C. Fault detection and diagnosis. PCs utilize advanced algorithms and data analytics techniques to detect abnormalities, deviations, or malfunctions in the manufacturing process and provide timely alerts for corrective action. D. Quality control. PCs facilitate quality assurance by implementing statistical process control (SPC) techniques, conducting in-line inspections, and analyzing process data to identify trends, patterns, or defects that may impact product quality. E. Process optimization. Through data-driven analysis and optimization algorithms, PCs identify opportunities for process improvement, efficiency enhancement, and cost reduction, leading to higher productivity and profitability. Components of process control systems. Process control systems consist of several key components, including A. Sensors and actuators. Sensors measure various process parameters, while actuators adjust equipment settings or material flow rates in response to control signals from the PCs. B. Controllers. Controllers receive input signals from sensors, process the data, and generate control signals to adjust process parameters and maintain desired setpoints. C. Human-machine interface, HMI. HMIs provide operators with graphical interfaces and interactive tools to monitor process status, configure control settings, and respond to alarms or alerts. D. Data acquisition systems. Data acquisition systems collect and store data from sensors and other process monitoring devices for analysis, visualization, and historical record-keeping. E. Communication networks. Communication networks enable seamless connectivity between various components of the PCs, allowing for real-time data exchange, remote monitoring, and centralized control. Applications of process control systems in semiconductor packaging. Process control systems find extensive applications across various stages of semiconductor packaging, including die attach, wire bonding, encapsulation, testing, and inspection. Some common applications include A. Temperature control. PCs regulate temperature profiles during solder reflow, curing of encapsulants, and thermal cycling tests to ensure proper bonding, curing, and reliability of packaged devices. B. Pressure control. PCs maintain consistent pressure levels during molding, potting, or encapsulation processes to prevent void formation, delamination, or warpage in packaged devices. C. Flow control. PCs regulate fluid flow rates and dispense volumes during underfill dispensing, adhesive bonding, or conformal coating processes to achieve uniform coverage and adhesion on semiconductor packages. D. Alignment control. PCs ensure precise alignment and positioning of components during die bonding, wire bonding, and flip chip assembly to achieve accurate interconnections and minimize defect rates. E. Quality assurance. PCs conduct real-time inspections, measurements, and tests to verify product quality, detect defects, and ensure compliance with industry standards and customer specifications. Thanks for watching.
Please like, share, and subscribe.